So there are different ways to indicate which conditions do we need to be in the sustainable quadrant. This is one of the examples, the one that I showed you before. But now we're going to come up with another approach. And this approach is the planetary boundaries. This is an attempt to define a safe operating space for humanity by analyzing the intrinsic dynamics of the Earth system and identifying points or levels relating to critical global scale processes beyond which humanity should not go. The concept was introduced by Rockstrom and collaborators, and in fact, he has made a movie about planetary boundaries that is now on Netflix, and you should definitely see it to understand this concept. The fundamental principle underlying a planetary boundaries approach is that a Holocene-like state of the Earth system is the only one that we can be sure provides an accommodating environment for the development of the humanity. For this, 9 planetary boundaries have been proposed, which, if respected, would likely ensure that the Earth system remains in a Holocene-like state. So the analysis have estimated quantitative boundaries for 7 of the Earth system processes or elements, including climate change, stratospheric ozone, ocean acidification, the nitrogen and phosphorus cycles, biodiversity loss, land use change, and freshwater use. For some of these, it is a first attempt at quantifying boundaries of any kind. That is, quantifying the supply of some of the regulating or the supporting Earth system services. There is insufficient knowledge at the moment to suggest quantitative boundaries for 2 of the processes, aerosol loading and chemical pollution. There are some criticisms about the establishment of these boundaries, and it is because, for instance, it has a precautionary approach. The approach may not seem fair to less developed nations who are balancing the need to manage environmental impact with the need to provide citizens with basic needs. So this is just one example of the issues associated to the establishment of these planetary boundaries. But there are some other examples. For example, the fact that these boundaries may change over time because there are some cascading effects or synergistic effects among these boundaries. Another criticism is the lack of information or the willingness to provide information by different agencies that limits the real quantification of the values for these boundaries. Regardless of the criticisms of the planetary boundaries, this concept has been widely adopted, and also it can be used as a tool for implementation of policies. Okay, now let's talk a little bit about each boundary. We're going to start first with the stratospheric ozone depletion. This is a layer in the atmosphere that filters the UV radiation from the sun. And this UV radiation, if the layer decreases, can reach ground level. And this can cause cancer to humans, and it can also damage the terrestrial and marine biological systems. Thanks to the actions taken as a result of the Montreal Protocol, this boundary is within the safe limits. And this is because there were some policies or actions taken aiming to reduce the release of compounds that were affecting or were depleting the ozone layer. Now we're going to start discussing loss of biosphere integrity. So this is biodiversity loss and extinctions. And because we have a dedicated module for this topic, I'm just going to mention that the main drivers are the demand of food, water, and natural resources that affect the biodiversity and can have collateral effects on the ecosystem services that we will also discuss in the following modules. So let's talk now about chemical pollution and the release of novel entities. Emission of toxic and long-lived substances such as synthetic organic pollutants, heavy metal compounds, and radioactive materials, represent some of the key human drivers of change for the planet. These compounds can have irreversible effects on living organisms and on the physical environment. Even when we uptake and bioaccumulate chemicals at sublethal levels, they have effects on reduced fertility, potential or permanent genetic damage, and can have severe effects on ecosystems. For example, persistent organic compounds have dramatic reduction in bird population and impair reproduction and development in marine mammals. The issue with this boundary is that there are many examples of additive and synergistic effects from these compounds, and these compounds are poorly understood scientifically. And therefore, there is no way of measuring this boundary. So let's talk about climate change, which obviously is a planetary boundary. And it is something that probably you have heard so much about it before. But still, we even with these conversations, we're still increasing the CO2, atmospheric CO2, to concentrations that can be irreversible for the planet. So because we have a dedicated module for climate change, we will discuss more about this boundary in the future. Ocean acidification is another planetary boundary. And when we talk about ocean acidification, we need to link this to climate change and to carbon dioxide. Because carbon dioxide can be released by the oceans, and they can also, oceans can also capture CO2 or carbon dioxide. So it is very important, the oceans are very important, and their acidification is a big concern for climate change. If there is acidification of the oceans, the carbon dioxide that has been stored for millions of years can be released and can be devastating. Later, we will discuss more in detail the carbon cycle in the oceans, and the ocean acidification relevance will be better understood. Freshwater consumption and the global hydrological cycle is part of the planetary boundaries. We're going to discuss this more in detail in one lecture, dedicated lecture. We can now discuss that it has been highly affected by climate change, and it is a boundary closely related to the climate, and also related to the stability of the climate. So human pressure is now the dominant driving force for determining the distribution of global freshwater systems. So as an example, nations build dams, and they can stop the flow of freshwater systems, which can affect other ecosystems around the area and can have a significant impact on the matter of energy flows. There are consequences about human modifications of water bodies, additional to what I have mentioned before, which include the global scale river flow changes. And another consequence is the vapor flows arising from land use change. And this affects the hydrological cycle and can increase or decrease rains in different parts of the planet. So let's talk now about one of the most important and dramatic changes in the planet, which is the land system change. Land is converted to human use all over the planet, and we are affecting wetlands, grasslands, forests, and all types of vegetation. And we are converting this to agricultural land. And land use is changing now, and is now the driving force of the biodiversity change. At the same time, this also has impacts on water flows and biochemical cycles of carbon, nitrogen, and phosphorus, and even also other elements. With each change of land cover at local scale, there is an aggregated impact and have consequences in all the Earth system, and also in processes that occur at global scale. So therefore, a boundary has been set for this, and at the moment, there is no way of measuring or a quantitative measurement of this boundary. The scientists have considered to use a spatial distribution or another type of tools to measure the boundary. But for instance, in the case of using spatial distribution, forests cannot be considered the same as the desert, for example. So nitrogen and phosphorus flows are also planetary boundaries. The biochemical cycles of nitrogen and phosphorus have been radically changed by humans. The nitrogen and phosphorus are both essential elements, and therefore we normally talk about these elements in terms of fertilizer loads and fertilizer pollution. Human activities have been able to convert atmospheric nitrogen to reactive nitrogen that can be used. And similarly, phosphorus has been extracted in more than ever before, and it is now a problem because it's mobilized by humans, and at the end it finishes in wastewater in aquatic systems. And this is the main cause of the algae blooms in lakes or in freshwater systems. The problem with nitrogen and phosphorus is that they can have significant effects on the climate and in our health. Some of the ammonia, one form of nitrogen, can be released as a gas during the use of nitrogen fertilizers. This ammonia can react with dust and can form particles that can affect our health. On the other hand, nitrogen from fertilizers can be released in gas form as nitrous oxide, which is a greenhouse gas that can contribute to climate change. So let's discuss now atmospheric aerosol loading. An atmospheric aerosol loading is a planetary boundary that has been proposed because of the influence of aerosols on the climate system. Through the interactions with water vapor, aerosols play an important role in the hydrological cycle, affecting cloud formation and global and regional scale patterns of atmospheric circulation, such as the monsoon system in tropical regions. They also have a direct effect on climate by changing how much solar radiation is reflected or absorbed in the atmosphere. Humans have changed the aerosol loading by emitting atmospheric pollution, and many of these pollutants condense into droplets and particles, and also through land use change that increases the release of dust and smoke into the air. Changes in climate regimes and monsoon systems have already been seen in high polluted environments. Another reason for an aerosol boundary is that aerosols have diverse effects on many living organisms, and those effects are not clearly understood at the moment. In this table, you can see the 9 planetary boundaries with their respective control variable, or the way of measuring the planetary boundary. The boundary that should not be surpassed, the zone of uncertainty, and the current value of the control variable are also shown. The zone of uncertainty is a range where the consequences are not fully clear. So a zone of uncertainty can be sometimes large or can be small. And it is defined in the figure as a yellow zone. This encapsulates both gaps and weakness in the scientific knowledge that is based on uncertainties on how the Earth functions. At the safe end of the zone of uncertainty, the current scientific knowledge suggests that there is very low probability of crossing a critical threshold or a substantial change can occur in the Earth system. But beyond that end of the zone of uncertainty, the current knowledge suggests that there is a much higher probability that there may be a change in the functioning of the Earth system that could potentially be devastating for the society. So this table shows the values that were found in 2022. However, these values may have changed in the future.